My name is Annie Lord, I'm a student at Liverpool University, and today I will be sharing a brief video on persistent identifiers. The learning outcomes of this video for listeners is to provide a basic understanding of what persistent identifiers are. The second learning objective is to understand various examples of systems and schemes in place that support the creation of persistent identifiers. And finally, this video will provide some insight into both the advantages and disadvantages of using PIDs. Whilst they are recognised as being born out of the digital age, the concept of persistent identification predates the internet. They have historically been used in scholarly work for the citation of paper-based documents. In this way, readers have a reliable link to reference sources. It was realised that when this concept of citation moved online, that identification was vulnerable to link rot as a result of web addresses going dead. Therefore, persistent identifiers were introduced as a way of stopping or slowing down this process. Persistent identifiers are defined by the Digital Preservation Handbook as a long-lasting reference to a digital resource. The two main components of PIDs involve a unique identifier and a service that locates the digital resource over time, even when its location changes. Another vital aspect to PIDs is that they are only persistent to the degree that someone commits to resolving them for users. To support this reality, PIDs are often created with institutionally administered systems, some of which are universally recognisable, such as DOI. The first example of a persistent identifier service that I'm going to discuss is a digital object identifier, or DOI. A DOI, like all PIDs, is used to identify digital objects uniquely. While they are primarily used and most recognisable in academic journal articles, they also feature in other places. The aim of a DOI is to facilitate access to the information object to which the DOI refers. This is achieved by binding the DOI to the metadata about the object, such as a URL, and this serves as an indication about where the object can be found. A key aspect to the DOI is that once it is assigned to a digital object, it remains fixed over the record's lifetime, whereas its location and other metadata may change. Thus, referring to a DOI is a way of ensuring a document can be found. However, it should be noted that because only the DOI is fixed and not the metadata or URL, the publisher has to update the database in order to maintain the actionable aspect of the DOI. The important and frequent use of DOIs in academic work ensures the reliability, authenticity, and accessibility of articles. Because of this, DOIs are now required as an aspect of full bibliographical references in many documentation styles, and they often facilitate further research and work. If the situation arises that the DOI cannot be located in an article, a free search can be made on Crossref, which stores data on millions of research papers that have been assigned DOIs. The second example of a PID service is an archival resource key, or ARK. ARK is a scheme for the persistent identification of information objects, which can include finding aids and other metadata, as well as digital archival objects. The scheme is currently maintained at the California Digital Library and has a number of institutions using the scheme, including the British Library. The ARK scheme is dedicated to ensuring the continued stability and support of the service behind the identifiers. Like a DOI, ARK is an actionable URL which links users to a digital object, the object's metadata and commitment strategy by the provider. In order to assign archival resource keys, an institution must become a Name Assigning Authority, or NAA, under the scheme. Each NAA is associated with one or more Name Mapping Authority host ports, or NMAH, which provide services for the digital objects being identified under the scheme. These essentially act as temporary addresses where the ARK requests are directed in order to make the ARKs actionable. These two links show how archival resource keys look once complete and the various components that make up the key. I have used a hypothetical example given by Manchester and Oxford's Paradigm Project resources on ARK to show the display of an archival resource key. The first aspect of the key is protocol. This does not form part of the identifier, but shows the protocol being followed. Following this is the NMAH, that again does not form part of the unique identifier, but identifies the provider of the services. The ARK indicates where the identifier begins. Then we see the NAAN, or authority number. This is the unique identifier for the name assigning authority. Next is the name component that's assigned by the NAA. Finally is the qualifier that can be used in a digital archive to express the hierarchies in a file structure. There are many advantages and disadvantages of using persistent identifiers and their host services. Firstly, the advantages have already been touched upon, but they comprise of PIDs giving authenticity and accessibility to digital objects. They combat the issue of URLs going dead, and as a result, they meet the needs of scholarly work through DOIs and digital archivists through ARKs. The disadvantages are fairly complex and, in ways, are reflective of most emerging digital preservation technologies. For instance, using the service of a persistent identifier scheme may be costly. It requires ongoing maintenance on service, and these are emerging technologies, and their longevity is not always guaranteed. Despite this and these disadvantages, in conclusion, I would put forward the argument that persistent identifiers are universally important for scholarly research and are an emerging asset to digital archives. They are contributing to the long-term infrastructure of digital preservation and reflective of lessons learned in relying on URLs. And finally, they need to be supported by services in order to remain valid. Thank you for listening. I have attached all sources used